Hi students, in this session we are going to discuss about non-parametric test for more than 2 sample. So, first thing is we are going to describe about Kruskal-Wallis test, which will be called as Kruskal-Wallis H-Test for more than 2 independent sample. So, what students are going to gain after finishing this module? They will be able to understand the methodology of Kruskal-Wallis test, then they will be able to understand the alternative test for comparing more than 2 dependent samples, which will be called as Friedman rank test. Then third one will be they will be able to solve the examples based on Kruskal-Wallis test and Friedman rank test, and at last they will be able to identify under what situation when these tests can be used. So, first we will discuss about the definition of Kruskal-Wallis H-Test. What actually Kruskal-Wallis H-Test does? Test the equality of more than 2 population probability distribution, corresponds to ANOVA, which will be called as parametric test for more than 2 means. It is used to analyze completely randomized experimental design. Uses chi-square distribution with p minus 1 degrees of freedom if sample size is less than or equal to 5. So, from this definition we can easily understand that Kruskal-Wallis test is nothing but a non-parametric test which is alternative to analysis of variance. In analysis of variance we will be comparing more than 2 means. The same thing we are going to discuss here in Kruskal-Wallis test. The only difference is we do not have any kind of assumption related to the data, whether it follows normal distribution or not. Let us see a practical scenario in which we can use the Kruskal-Wallis test. For example, a shoe company wants to know if 3 group of workers have different salaries and the salaries are mentioned in thousands. If suppose we have only 2 groups, then we can perform the 2 independent t test, but in this scenario we have 3 groups. So, you can see we have third group and the 3 groups represent the first age group as 21 to 35 and second age group as 36 to 50 and third group as 51 to 60. So, in this case we have to compare all the 3 age groups at a time. So, for better we can use the Kruskal-Wallis test, which will be a suitable one for comparing this kind of example. So, how to do the Kruskal-Wallis test? This is nothing but first we have to frame the null hypothesis. So, first null hypothesis is nothing but H naught, the k probability distributions are identical, and the alternative hypothesis is nothing but at least 2 of the k probability distributions differ in their location. So, the test statistics is nothing but H. Kruskal-Wallis test, the test statistics will be mentioned as H, which gives the formula as 12 divided by n into n plus 1 summation nj and rj bar minus r bar the whole square. Let us see about what this expression tells about, where nj is nothing but number of measurements in sample j, rj is nothing but rank sum of sample j, where the rank of each measurement is computed according to its relative magnitude in the totality of the data for the k samples. Next, rj bar, this is nothing but we have to take the sum and we have to divide by their number of observation, which will be called as mean rank sum for j sample, and n is nothing but the total sample size, which will be called as n1 plus n2 plus up to nk, and the last one is r bar. This is nothing but the mean of all ranks what we have calculated, and for the general case this is nothing but n plus 1 divided by 2. Next, the comparing k probability distribution, we will know about the rejection region. So, what will be the rejection region? So, we have to calculate the test statistics value, which is called as H, and which should be greater than chi square with the k minus 1 degrees of freedom. So, next we will discuss about the ties. Under Kruskal-Wallis test, how we are going to deal with the ties. So, as in any tied observation, the average of ranks they could receive if they were unequal but occurred in successive orders. For example, if the third ranked and fourth ranked measurements are tied, that is third and fourth, assign each a rank of 3 plus 4, take the average divided by 2. So, the third observation and fourth observation will take the rank as 3.5. The number should be small relative to the total number of the observation what we consider. Next, what are the conditions required for checking the validity of the Kruskal-Wallis test? The k samples should be random and always be independent. There should be at least 5 or more measurements in each sample. The k probability distribution from which the samples are drawn should be a continuous one. Next, we will discuss about what are all the procedures involved to do the Kruskal-Wallis test. First thing, as a inner rank to the n combined observation. Suppose if we have 2 groups or 3 groups, combine everything, take the smallest value as 1 and largest value as n and if you have average rank, give the tie as we told earlier. Then sum ranks for each group. Then at last calculate the test statistics. The test statistics will be calculated as H, and we know that formula as 12 divided by n into n plus 1 summation rj square divided by nj minus 3 into n plus 1. The notations given in the formula are already discussed, and you can see there that rj square is nothing but the squared total of each group. So far we have discussed about the definition of Kruskal-Wallis test, and further we have discussed how to proceed with the Kruskal-Wallis test, and at last we have discussed about how to calculate the test statistics value for Kruskal-Wallis test. So in next session we can discuss about Friedman rank test for more than 2 dependent mean. Thank you.